going to be doing our last lesson for Unit 3. So after we finish this today, you guys will have a short assignment over this information, and then the rest of the time we're in here today will be used as time for you to review. If you haven't already, make sure, if you were absent, that you go back to the folder after we finish the notes and get all the missing papers, including the review from back there, okay? All right, so our last lesson is how to construct angle bisectors. So just like always, whenever we learn how to do a new construction, they list out all the steps for us. The first step, they say, is that whenever you're given some angle, like we are on example 1, your first step is to take your compass, put the pointed end of your compass on the vertex, or in this case, point A, and your pencil end somewhere on that bottom line, and then they just drew an arc that went through both lines. So they had it here and here, stood it up, drew an arc, right? Okay, second step is to then take your compass and put it at one of the points where that arc you just drew intersected your two lines. So it intersected right there and right there, and they name those points C and B. So when it's talking about points C and B, that's where those came from, okay? So they say first to take your compass, which means the pointed end, and put it on point C. So that would be like right here. And then you put your pencil end somewhere in between the two lines. So it looks like they put it here, stood it up, and made an arc right there. Okay. Then without changing the width, you're going to come over here, put your pointed end on B, and make the exact same arc, and they should end up crossing. Okay, so once you have drawn these two little arcs out here, since you didn't change the width at all, not only do they cross, but they should cross exactly in the middle of those two line segments or rays that were already there, okay? So once you have that intersection point, they said they named theirs point G. The final step is to take a ruler or a straight edge and draw a line that goes through point A, your vertex, and point G, where those two intersected. Okay, so those are going to be the 3 steps we take to construct angle bisectors. All right, so let's use that to help us construct a bisector for example 1. All right, so the first step they said was we were going to take our compass and put it on point A, and then your pencil end anywhere on that bottom line, doesn't matter where, kind of like our first step once we're trying to make a congruent angle. And you just need to draw an arc that will go through both the top and the bottom lines. Got to go through both. So there's my arc. And it should have intersected both the bottom and the top line. Okay, if I was to name these like they did, then I could say that this is like my point C, and this is like my point B. All right, so does everybody have that arc drawn? Okay, after we draw that arc, it then says to pick your compass up, put your pointed end on point C, and the pencil end just needs to be somewhere between the two line segments. So it could be over here maybe. Stand it up and draw some arc. Okay, without changing the width at all, pick it up, come down here and put it on point B and draw another arc. Okay, if you don't change your width at all, not only will they cross, but they should cross right in the middle of this line and this line. Okay. If you accidentally change the width a little bit, it will shift that point left or right. So make sure you don't change your width when you go from drawing this one to drawing that one. Okay. Guys, so do I need to go back over again how to draw either of those segments, or we got that? We're good there? Okay. So they said that you could give this point a name, so maybe we'll name it point G, just like they did. Then I'm going to take my straight edge and draw a line segment or a ray that goes through both point A and that intersection point, point G. Okay. So there's my ray. And now this ray should be right in the middle of the angle that was already drawn for us, which makes it an angle bisector. That's what an angle bisector is. It cuts an angle in half. Okay, so I should be able to make the same statement that they made right here, since we used all the same letters. Here, the ray AG, and yes, we do have to put A first because it was our endpoint, should bisect the entire angle A. Okay, so let's say that you were trying to write a proof based on some drawing like this, and you needed to come up with some statements. Well, there's a few things that I could say about this, guys, if it cuts it in the middle. Okay, so let's make a list of some of the statements that we could make here. Okay, first of all, if this line actually cut the angle right down the middle, what would I know about this angle right here and this angle right here? They are congruent, right? So I could say that the top one, which we would name maybe CAG, say that angle CAG is congruent to angle here on the bottom, GAB or BAG, whichever way you want to name it. Should be congruent, yes. Okay. We also could make some statement about the entire angle in comparison to one of these. So the entire angle would be CAB, right? So I could say that the measure of angle CAB, which is the entire thing, how could I say, or what could I say about that in comparison to just one of the angles? So maybe just this piece. Right, double or 2 times, right? So it would be equal to 2 times the measure of either the top one or the bottom one. Maybe we say the top one, which was CAG. Okay. I also could make a statement about one of the angles in reference to the whole thing, which, yes, one of the angles is half of the whole thing. So maybe I would say something like the measure of this bottom one, angle BAG, would be equal to, like he said, half of it, or to divide by 2 of the entire angle, which we said was CAB. Okay. And you could use either angle to fill in both of these places, right? Either one would work. So if you were needing some statement or proof, you could use any of these. All right. So once you guys have all those statements written down, we're going to do one more just like it. So let's look at example 2. Okay, so again, remember the first thing that we should be doing is taking our compass and putting it on the vertex of the angle, which is point A on this picture. And then you put your pencil end somewhere over here. Now remember, the further away you make your pencil from that point, the bigger your picture is going to be. So just keep that in mind. And then you just need to draw an arc that's going to go through both of these segments. All right, and then remember, wherever that arc intersects your 2 line segments, you have some intersection points that you can give a name to. You can name them just like last time, C and B, if you want to switch their spots. Still means the same thing. If you want to pick different letters, you can pick different letters. The names of them don't really matter, okay? All right, and once we have that arc drawn, You then put your pointed end on one of those points, doesn't matter which one, and your pencil end beside it, and you're just going to draw some arc through your figure. Then without changing the width, come over to the other intersection point and draw something similar. Okay? And as long as you don't change your width at all, they should intersect exactly in the middle. Now, your point might end up being out here, like outside of the arc you drew. It could be in here. It's all going to depend on how far apart your pencil was from the vertex when you started. But as long as you have a point where they cross, it's still the middle, no matter what. And you can, again, name that anything you want. If you want to name it like they did in the example, we'll name it G. Our final step, take our straight edge and draw some ray connecting point A and point G. And then again, I should still be able to make the same statement that the ray that we just created, AG, bisects the entire angle, which was angle A, right? And again, all of these statements should still be true. I should still be able to say that this piece and this piece are what? Right? So that would be angle CAG is congruent to angle BAG. Okay. I should be able to say that CAG, this one right here, is how much in reference to the entire angle? Half of it. Very good. So angle CAB or BAC, whichever way you want to write that. All right. And then BAC, which is the whole thing, what is that in reference to one of the pieces? 2 times either one of the other pieces. Huh? Yeah, G. Did you say GAB? That would work. All right. So any questions on those? Are we good there? Okay, once you have all those statements written, if you'll flip it over on the back, there's 2 multiple choice questions over construction. So this is something that you might could see on the test if they asked you a multiple choice question about constructions, okay? So, number 3 says that the diagram below shows the arcs and segments used to construct the line MN. So they constructed this line when all they were originally given was the point P and the line LR. So they used the same instructions apparently that we know about to create this line. And what they're asking us now is, based on this drawing over here, which statement below is not true? So that means we're looking for what could be false, right? Okay, so first answer choice says that QR, which would be this little segment right here, and PN, which would be this little segment right here, that those should be equal. Is that true or false? True, right? Because they were made with the compass and we shouldn't have changed the size, right? Okay, so this one is true because compass width didn't change. Okay. All right, so it's not F because that one was true. All right, G says that the measure of angle RQP, so RQP, that would be this piece right here, is equal to QPM, which would be this angle right here. True or false? True. Why? Alternate interior angles. They are on opposite sides. And we know that alternate interior angles are congruent. Good. All right. Then it says angle LQP. So LQP, that would be this one right here. I'm going to mark it with 2 lines so that we know we're talking about a different pair this time. Is complementary to QPM, which would be this bottom one. Okay, so what does complementary mean? They make a 90 degree, right? They add up to 90 degrees. Well, is that what that type is supposed to add up to? No. What type or same side interior is supposed to add up to? 180. 180. So that's probably going to be my answer, right? We can double check this last one. It says QPM. QPM would be this one right here. And NQP, or NPQ, sorry, NPQ, this one right here, are a linear pair. Well, that's true, right? They're on that straight line. So it would be answer choice H. Okay. All right. Then we got number 4. So it says that they used a compass and straight edge to construct the line segment FH, this one down the middle, in the given triangle DEF. Okay, again, they want to know which statement does not necessarily have to be true. So we're looking for something potentially false. Okay, answer choice A says that DE, which would be this bottom line here, has to be equal to EF. Not necessarily. So that could be it. We'll put a question mark by that one. Okay. Next one says that the angle DGF, that would be this angle here, is a 90 degree angle. Right, because those are what kind of lines right here? Right. Okay, so that one is true, so it can't be that. Half of DE, this bottom line, is equal to GE. Right, it's supposed to cut it in half, so that one would be true. And then the last one says that DG is equal to GE. That's also true, so it does have to be answer choice A. All right.